Hey everybody, welcome back to another lesson in Greenfoot. I hope you're having as much fun as I am. I love getting to watch code that I make interact and behave immediately without having to do too much extra coding for the graphics. So let's get right to it. Today, I want to make a boat battle project. Now, we're not going to finish it, but we're going to get a good long way and get to give you some ideas. Start having these brainstorming sessions about what kind of projects that you could do. So what I want us to do is make a world that is 600 by 600. I've made a new project. I called it Boat Battle, and I'm gonna make my world 600 by 600. Again, I'm gonna stick with it just being one cell for now. Sorry, each 600 by 600 pixels are cells, each cell 1 pixel wide. All right, and that should be good enough for now. Now the backgrounds, I wanted to make this an ocean, and they have kind of a watery thing. It's just not that great, so I decided to draw my own. There you go. So I just made a 600 by 600 image, and I used the fill bucket on my Microsoft Paint to make it all blue, and then I just drew a white wave. And when I found one I kind of liked, I just copy and pasted it around everywhere, and I saved that to my folder as to my pics folder as just ocean. So that's exactly what I'm gonna do. I'm gonna go down here to this little gear, and I'm gonna import an image from my library, and I am going to import. See here from pictures, I'm going to select ocean. All right, super. Now we're going to make a sailboat. So let's create an actor here. Well, let me hit reset. Make sure that image comes out the way I like it. Perfect. Let's make an actor. I'll make a new subclass here called sailboat. And I do like the image on this one, so I'm going to go ahead and go to transport, and I'm going to pick this little sailboat right here. Okay. And that looks good. Right now we don't really need a constructor, but we might need one later. So and I'll let you fill all this in as you see fit later too. But we're probably going to need a constructor later for what I want to do. But let's just leave this off for now, and let's go straight to the act method. And we're going to follow the same protocol that we're going to try and do things, just one step at a time in the act method so it doesn't get overloaded. All right, well, what I'm going to do is I'm going to write a method called set direction. And set direction is simply going to set the direction that the boat is going. And then whichever direction we're going, we're going to move 2 cells in that direction. And then we're going to fire our cannon ball as necessary. Let's come back. We'll write that one later. Let's come back to that one. So let's just worry about moving right now. Okay, so to set the direction, that's what we need that first, right? Public. I'm not returning anything, it doesn't look like, so we'll just say void set direction. And this is where we're going to get some user input. So the Greenfoot documentation, let's go here to help, and we'll bring up, we want Greenfoot class documentation. So we can already pull up the documentation of world and actor fairly easily, but there is some additional stuff that we need, including sound. I don't know if you played around with adding sound yet, but we won't do that today, but we'll do that. We'll definitely do that for this project here before we call it quits. So you can see that's where you add sound. This controls images. We're going to need to use that today. Let's go ahead and take a look at Greenfoot is a utility class. So all the methods are what we call static, just like math class methods. They're called directly on the class name itself. So lots of different things you can do here, but I'm going to be using is key down today. Okay. So is key down is where it's at. So because it's a static method, we're going to call it on the name of the class itself. We're going to say if Greenfoot, that's the name of the class, is key down. And we have to tell them the key, and they're usually just lowercase words. You can look them up on the internet. It's not clear in the documentations. You have to go to a different place to find them, but they're pretty much what you would expect them to be. All right, so I have if Greenfoot is key down left. Now, we haven't discussed static methods that much yet. We will, trust me. But most every method that I've had you write, actually every method this year that I've had you write, has been what we call instance methods. They're the vast majority of methods. A static method is a little different, and it's just for simple things like math or, hey, is the person pressing the keyboard key down? It's not for making a sailboat move or really doing a lot of work like that. A static method is more like a function. It's a very basic thing. So when you call a static method, when you see it, let's go back and look at the documentation. You'll notice that these are all public, because if it doesn't say it, it's public. And then it's the word static, and this is typically the way it is. You don't mix static and not static in classes usually. So we make a utility class, and all the methods in there are static. But most of our classes are not utility classes. They're classes for making objects, and they have methods belong to objects. So whenever you see that word static, it just means you don't have to make like a new Greenfoot. You just say Greenfoot dot is key down. All right, so if Greenfoot dot is key down, and we're going to say left, well, let's turn 5 degrees. Now, turning on the Greenfoot thing here, 0 degrees is directly to the right, and because y is going down, we're actually going to turn like that. So we're going to be turning -5. So I have turn -5. If Greenfoot dot is key down, we turn -5. Then I'm going to say if Greenfoot dot is key down right, I'll turn +5. This way, if they have both of them down at the same time, because maybe they still haven't lifted off the other one yet, the turns will just cancel each other out. It'll turn 5 one direction, then turn 5 the other. But if you have just one key down, it will actually make an impact. Okay, and that's it. Okay, I think I like that. Let's give it a shot. So let me reset our code, and let's make a sailboat. And let's run it. Okay, so you can see that I can turn left and I can turn right. You know what I don't like? I don't like that it kind of, you see what happens is it spins around too much. What I would really like is to be able to have the image kind of change. See, I don't want it to be upside down like that. I don't like that. I don't like that. Do you? No, I don't like it. I mean, I guess it would work if we were doing a completely top-down view. But for the way this sailboat is, that just doesn't make any sense. So let's fix that. Let's definitely fix that. We don't want that. So what I want to do is I'm going to make some mirrors to my sailboat. So let's go ahead and make a sailboat constructor. Public sailboat. And I'm going to make it set a couple of images. Okay, so I've got my original image that I need to set. So private Greenfoot image. And I'm just going to call this right. This is when it's facing right. and I'll say private Greenfoot image left. Okay, so the right image is going to be set by the image that we're using right here. So let me go ahead and look at that right quick. Oh, it needs compiling. It's not going to let me do it until I finish compiling. That's okay. I'll just say null, just for a second, just so I can compile. So if I go to set image, you'll notice that you have these images in here, and they're typically PNGs, although some of them are JPGs. To get the details on it, you can open up in your File Explorer, and you can go to the specific place where you saved this project, and you can open it up. There's my boat battle, and you'll notice all the images are copied in here. And I want to view details, so I'll go view details. You can see it's boat01-f PNG. So that's the file name I'm going to be using, okay? So I need that one. So, and the way that you create an image, let's go back to our documentation now. We're doing something different, so we got to go back to our docs. Go back to my Greenfoot package here. Greenfoot image. All right, it's got a constructor, okay? And it's got, here's one right here. Greenfoot image, that's the one I want. You give it a string of a file name, okay? So that's the one we're going to be using. So it's the way we make an object is we say new, then the name of the class that we're instantiating. And I bet you don't remember the name of that file, because I don't either. It was boat01-f. .png. Because it's a PNG file. Okay. Cool. Now, let's make my left boat. Left is equal to... Now, this is going to look like it makes no sense whatsoever, but it's the way we have to do this, and I'll show you why in a second. I'm going to make the exact same image. But it's two different images with it's two different instances of the image class, okay? And you see these images we have here. We can draw on our image. I could add any kind of shape I want, an oval to it. I can do anything I want. You can make a blank image and draw on it if you want. But that's what I want right there. I want to mirror this vertically so that it's not going to have that upside down look, because that's the problem. The boat's sailing this way, and it's fine when it's facing that way, but it's upside down. So I'm going to mirror vertically. That's what I want to do. And that method, you'll notice, is void. It actually it doesn't return a new image. It doesn't like copy the image mirrored. It completely changes it. So let's do that. We'll say left dot mirror vertically. There we go. So now we have two different images to choose from. We're going to let our original image just stick with what it is. The original image is actually our right image. Okay? Okay, so now that we've got that, we've got this set direction. Let's go ahead and set the image that we're going to have as well. So when we set our direction, we're also going to set the image that we'll use. So I want to make a method that we can call, because this is going to get really crowded anyway, that tells us if our boat is facing left or right. So let's write that method. So let's think about what kind of thing we're kind of figure out. We're going to figure out, are you facing left or are you not? So, in other words, is it true that you're facing left or is it false? So that's a Boolean. So I want this to return a Boolean. So I'm going to say public Boolean is facing left. And this is good coding habits. This is something we're going to use several times. I don't want to do all this logic everywhere. It's difficult to read. So if you're facing left, let me pull up my paint right quick and show I can draw this. So typically, the way this works is your objects are pointed to the right. That's 0 degrees rotation. And in math, we're used to rotation actually being counterclockwise. So this would also be 360. But because the y-axis is down in this graphics, there's y and then there's x. This is actually the direction of rotation. So this here is 90 degrees. That's 180. And then this is 270, okay? So if you're facing left, it means you're over in this region here between 270 and 90. And that's not going to be hard for us to code. So I'll say return get rotation is the name of the method. It's in the actor class. You can look at it. It returns the direction that we're rotating. Well, if it is greater than 90 and less than, and get rotation is less than 270, then we know that we are in that, facing that direction. We've rotated past this way, but not past this way. So, and I'm just going to return that value. So, yeah, if let's say the rotation was 120 degrees, well, then this would evaluate to true, and this would evaluate to true, and true is true, so we would be returning the value true. Okay, so now that we've got that, I'm going to say if is facing left, then I'm going to set my image, that's another function here, set image to the left image that we have. Set image left. Else, set image right. Okay, I'll compile that. I don't think I need that anymore right now. Let's reset there. Okay. Gonna make a sailboat right quick. There it is. And we'll let it run. And I'm going to turn and you see how it allows me now to face to the left without it looking like it's upside down. So that's what I wanted to do. So that's pretty great. Okay, I'm happy with that. All right, on to the next thing. Firing. We want to fire a cannonball. So let's make the fire method. Public void fire. All right, so I'm going to use spacebar to fire. So I'm going to say if greenfoot, I'm on caps lock for some reason. If greenfoot dot is key down space, and is key down is the method that returns a boolean, so it's returning true or false where that key is down. Then I'm going to fire a cannonball. And what I'm going to do is I'm going to do this in kind of a bad way first, and then we're going to fix it. But I want you to see this in case, so you know how to handle it. So we're going to make a cannonball object, but before we do that, we need to make a class for it. So I'll make a new subclass. Come on. New subclass called cannonball. And I've got one right here. So there we go. All right, so what's our cannonball going to do? Well, our cannonball is simply going to move however far it's told to go. So let's have a speed for our cannonball. That'd be good coding. I don't want to just put in magic numbers. I'm going to say private int speed. That's how far it goes, okay? And I'm going to say move speed. See, that's going to be a little bit better to read. Now you don't have to, you know what that is. But how do we set speed? Well, we should do it in a constructor. So let's do that. So public cannonball. Now remember, before I wrote this, Java made one for me that was blank, except for it says super. You don't technically have to say super in Java. It does it for you. Sometimes you have to if you have to send it something. But for now, we're just going to say, I'm going to go ahead and put it usually because I like being explicit. All right, so speed equals, let's try 5. All right, and we're going to act. And we're simply going to move speed. But I need to make sure that I have a way to set a direction. So I'm going to say public void. Because we're going to shoot in 2 directions. We're either going to go up or we're going to go down. That's the only 2 things we're going to do. I'm going to say point up. All right, and if we're point up, we're going to set rotation to 270. Because remember, it starts here and the y-axis goes down, so it goes like that. So 270 is all the way around and back up again, 270 degrees. And I'll say public void point down. And this method will simply point us downward. Okay, great. So we had the ability to point up, point down, and we move at a speed. And right now, all the instances will have that speed of 5. And I think that's fine for now. There's one other issue. There's a couple issues we're going to have to deal with, but I want you to kind of see these things and how I handle them. All right, so back to the cannonball. So if the key is pressed, well, we need to figure out, is that cannonball going up or down? What I want to have it is, if the sailboat's going this way, I'm just going to pretend the cannon's only on one side of the boat, okay? So if the boat's going that way, I want the cannonball to go up. So how do I do that? Well, I ask if I'm facing left, right? So I say if is facing left. We wrote this method, right? It does this for us. So if is facing left, then if we're facing that way, we're supposed to shoot down. So I'm going to say, I'm going to tell this cannonball to shoot down. Well, I'll tell you what, let's make the cannonball first. So cannonball, how do you make an object, y'all? You need a type. It's going to be of type cannonball. I need a variable name. I'll just call it ball. And then I use the new operator, new cannonball. Just like that. Okay? Now, if I'm facing left, then I want the ball dot. Now, I've already forgotten. I wrote the method. I can't remember what it's called. What was it called? Point down. Point down. All right. Ball dot point down. Okay? And yes, I could have said ball dot set rotation. I could have actually done that, but I like to make these different methods. It's good. It makes it more readable. Else ball dot point up. Okay. So if the ball, we're going to either point down or we'll point up, depending on which way we're facing. Now I need to add the ball to the world. Now, it's been a little while since we did that. We've only done it in the world class, but we need to add it to the world. So the first thing I need to do is get an instance of the world. But I'm not in the world class. I'm in the sailboat class. So first, variable name, variable type, world. Variable name, we'll just call it W. But remember, there is a get world method that returns the world that the sailboat is in. So I just say get world, and it returns that instance. Now I have all my world methods available to me, and I have add object. And I'm going to add the object, cannonball, and I have to tell it where I want to add it. Well, I want it to come like it's coming out of the boat, right? So I'm going to say get x to get my x coordinate of my boat, comma, get y to get my y coordinate of my boat. All right, I think that's good. All right, and let's try and run it. Now, hopefully you see the issue I'm having. When I'm filming, my Greenfoot does not run as nearly as well as when I'm not filming. So, but all right, reset. Let me put a sailboat out there, and I'll run this. Okay, well, yeah, that's the problem. Yes, that's there you go. Um, I can fire downwards though. I think, yeah, it does go down, but I see a couple issues. One, the cannonball is huge, and two, I can fire like 100,000 of them by just trying to press it once, and that is not good. And the reason why that's happening is the frame rate. At least it should be when it's working. The frame rate is fast enough that I'm not able to release the space bar. And I don't want to make it to where they just press it and get to like hold it down like a Gatling gun or something. I want it to be like they have to press it. So I want a little bit more control over that. So let's go back to the sailboat and let's do something else. I want to make a variable called space down. Okay? And we'll start with that as false. So space down is false. When we fire, they can only fire as long as the space key is down and the space down key is false. So I can say space down equals false, or I can say not space down. So you can say this, but I don't like that. I just find that kind of clumsy. But you can do it. It works just as fine. It's a matter of choice. I just like to say, I like to read that. So if key down space and not space down, meaning not already had the space key down. And then the first thing I'm going to do when you do this, I'm going to say space down equals true. Okay. But I need to reset this. So I'll say else if not green foot dot is key down space. Space down equals false. So basically now we've got these three different situations. If they're pressing the space key and they were not previously pressing it, we're going to fire a cannonball. Else, if they are not pressing the space key, then we're going to set space key to not being pressed down, the variable. And then the third case, which you don't really see me doing any code for at all, is that the space key is down and it was down before in the last frame. So that's how we're going to control that a little bit. Next, let's deal with this cannonball issue. There were a couple different issues with it. One, it was huge, right? It was huge. Let's fix that. We have the Greenfoot image class. Let's use it. Greenfoot will automatically supply one image to the cannonball based on what we selected over here. So we can just simply get that. So I'm going to say Greenfoot image, I'll call it img equals get image. So this is going to get me a reference to the image that I'm using, and so now any changes I make to img will affect the thing that I see, and I'm simply going to scale it down to 10 pixels by 10 pixels. You can do whatever you want. Okay, so now the image is smaller. That part wasn't hard, right? That was not difficult. All right, now what about when we had this cannonball, and if you notice, we would fire it and it would hit the top or the bottom and just sit there. We need to have a way of removing it. So let's deal with that. So when we move, after we move, let's remove our cannonball if we're off the screen. So I'm going to say if is at edge. Remember, you don't have to have these memorized. They're all right there. Just double click on the actor class, bring it up. Just remember that there's something that allows you to do that. And go to your is, you say is at edge. That's what I need. So if is at edge, I need to remove it from the world. So Removing an object from the world, though, it belongs to the world class. So I have to get an instance of the world. So I'll say world. I'll just call it W equals get world. So get world is a method in the actor class. So I got to open. We'll look at it. Get world returns the world the actor lives in. And then I say W dot remove. Okay. Remove object. Okay, well now this is tricky because this is the first time we've seen this. How am I going to tell it to remove myself? I'm in the cannonball class, and we're going to have lots of different cannonballs. I don't want to remove all of them. I want to remove just the cannonball that I have, right? That's the one that this code is being called on. Remember, this act method, if we have 20 cannonballs, then, Greenfoot's going to call act on each one of those cannonballs one at a time. And each time they're going to ask, am I at the edge of the world? And if the answer is true, then we need to remove that object. And the object that you are right now, that you're dealing with, is called this. In Python, it was called self. In Java, it's called this. So remove what? Remove this. Remove me. And that's it. Let's compile it. Let's take a look. We should be able to run around the screen. We should be able to fire our cannonball and hopefully have it be a reasonable size and not do 800 of them at a time. And notice that they'll also fall off the screen. Oh. All right, this is getting set for being a very fun game. I'm excited about being able to make targets and do such like that, and even make a scoreboard. So I'm looking forward to our next time together where we get to keep playing this some more. But until next time, take care.